Hey everybody, welcome back to Video Game. So, continuing series on the MiSTer FPGA D10 Nano project, more specifically in this instance what I'm calling Conquering Conker, where I try to figure out exactly why Conker's bad fur day is freezing on the core and see what can be done about it. And just recently I did purchase an EverDrive as well as an original Conker cartridge, which I'm going to modify and get some data out of a real Nintendo 64, but in this instance we're going to be using Aries and the core to try to figure out the differences and what might be going on under the hood. Before I get too far involved though, do me a huge favor, down below hit like and subscribe and ring that notification bell, definitely helps. If you feel like supporting the channel, we got a Patreon link down below as well, because I am $300 into this project and I'll probably have to spend more. But I have found some very interesting results comparing the core against Aries, and I will go over all of those in the video. You'll see here core on the left, Aries on the right. In the first video I showed you one of the instances where this game was freezing randomly, and it's going to freeze in one of a few different manners. You're either going to get a CPU halt error, an RD error, or a memory out error, but it all seems to be memory related, and we're going to be talking about that in the video, showing you guys some hard data numbers to explain exactly what I think is going on and where we could kind of go forward on this. You'll see here that we ran out of memory on MiSTer FPGA. The heap is just a memory allocation where all of the RAM can be allocated to the developer's wishes, and you'll see here when we move back to the MiSTer FPGA capture again and run through this area a second time, we get a different result, and that result is that it doesn't crash. So again, these random crashes that do not replicate themselves are the hardest things to track down. You want consistency in issues, that way you can kind of go through debug and look through them, and unfortunately in Aries I was not able to get the prototype to crash, so I don't really have any great debug data out of there, but I was able to use the info cheat code on the actual prototype across both the core and the emulator, and I did find some fundamental information that I think is going to be important moving forward. MiSTer on the left, Aries on the right. Look at the free and largest free memory allocations across MiSTer FPGA as well as Aries. You're going to see that MiSTer FPGA is utilizing more RAM and it has less RAM addressing free compared to Aries. Now I'm still not 100% sure the reason behind this. I do need to do more research, and if you take a look at the bottom of the screen I have kind of put that data up just so you can take a look at that. But the largest free is always going to be larger on Aries than it is on MiSTer FPGA. So now I'm starting to think if those heap out of memory errors are there, perhaps it's a situation in which the core just doesn't have the same allocation of free memory available to the actual application when it's running, and maybe we're overrunning the memory in that instance, because across all of these locked off cutscenes, and I will show you more later, I cannot get the same specifications out. You will see the frame rate fluctuates a little bit differently between both, but that's really not what I'm so much interested in. I'm interested in that memory allocation. You get the bars there, you get everything you need to see that this cutscene on the Aries side of things always has more free memory than on MiSTer FPGA. So that is the first direction kind of to research more and work in, and when that EverDrive cartridge comes in I can run this prototype on real hardware with the prototype variant and get the same data, so I can put them side by side and show you, and most importantly understand exactly what everything is doing across the board. That is where I am right now. I am still just trying to ingest different data so that I can better understand exactly what's happening, so I know the direction to potentially work moving forward. And again, I'm going to be very clear about this entire thing. It is as likely as I fail to get this crash free as it is that I can get it crash free. I am not promising anything. I am just having fun showing you guys what happens under the hood and kind of taking you along for the ride of what I'm calling Conquering Conker. Because here in Aries, the same area that I was able to freeze in the core, we're going to try to do the exact same thing and see if we get a different result. That is the definition of insanity, by the way, and that's probably what I'm doing right here, an insane attempt to fix something that honestly with 5 crashes in an entire playthrough, you should probably just play it like that. But you'll see here as I hop around, I'm not able to get this to crash in Aries, and through my entire playthrough, I'm like 2/3 of the way through Conker for the second time, and nothing has crashed on me. Now if we move back to my original capture on MiSTer FPGA, we jump down basically doing close to the same thing, and we're going to get a freeze, but do be aware, trying to replicate these one-to-one is absolutely impossible. It just kind of is how it works. You'll see that RD bug trace there as well. Now moving back over to Aries, going through all of the different areas, The performance on software emulation and the performance on the core is 1-to-1 until the core crashes. I'm not trying to say one is any better than the other. That's not why we're here. This isn't a comparison. This is a data finding mission, and that's what's really useful for me. And I have some other people testing. I will tell you when their footage comes up as well. And if you want to test this with me, just contact me on Twitter or Discord, and I will tell you what I need and how you can help. Honestly, all you need to do is play Conker and report any of that crash data to me. I just need to know the numbers. But on the Aries side of things, you can play this game. It is awesome, and that is always a fun time. And I want to get the MiSTer FPGA version over to the exact same standard of performance. Now let's move over to another capture here so we can kind of take a look at what else is going on. So this was set in by Tarkovsky Mirror. Big thanks to him. He's over on the MiSTer FPGA Discord. There are a few other people testing and sending me data as well, which will appear in future videos. But he has had a better, more stable experience as well, and that's pretty much been reported across everyone who has been testing this. The crashes are much less frequent, so I think the next step is going to be to have to compare the retail ROM and the memory usage against Aries with the non-prototype version. It's going to be another data set that I'm going to have to capture, and maybe I'll put that in a video, maybe I won't, but you'll see here everything is going to be stable again until it's not. So we will see the crash in real time, and we'll kind of take a look through what's actually happening with the crash handler underneath. And it's a great thing that this game has a crash handler when the game does crash. This is where I'm getting 90% of all of the useful data out of. So Conker is going to pop out his Game Boy here, and the game is going to freeze, and we're going to see that same RD bug trace. I'm assuming this is the reality display processor, so maybe something's going on in here. You're going to see CPR2 is unusable. Now I am checking in with some people that do Nintendo 64 development, giving them some of these codes to try to better understand maybe what's going on. I need to do a little bit more tracking on what these bugs actually stand for. Some are very obvious, like heap out of memory, that is out of RAM. Other ones I'm still not 100% sure on. But as we run around in this area again, you're going to see the next crash that was sent into me, and it's going to actually occur during a loading zone, which I have never seen in my testing. So again, a lot of variables in how this works. Conker pops into the knot hole and the core freezes. If we're going to go ahead and press the button, you're going to see that RD bug trace is going to pop back up again. So that is very interesting information, and it will prove to be useful. And that's why I'm testing against Aries until that EverDrive comes in, and then I can start testing this prototype version against real hardware. And here is my hope. I want real hardware to crash as well so I can get the data out. If real hardware doesn't crash whatsoever on the prototype, I'm not really getting much data out of it except knowing that it does in fact work 100%, which in and of itself, if that's what happens, is useful information to have. And that is why I actually like doing these things and kind of digging through. I love hunting rare hardware, I love hunting rare arcade PCBs, and now I am hunting bugs in Conker's Bad Fur Day on the MiSTer FPGA core. And honestly, my personality, I love to solve problems, so this is a fun one for me. Now if we put Aries next to MiSTer FPGA again in a different cutscene, you're going to see the same result. The free memory allocation is larger, the largest free allocation is larger. Pretty much everything is going to be running slightly more efficient on the Aries side of things. Now, is that just because Aries has some sort of change in how it's coded? Possibly. They are only using 8 megabytes of RAM. I did go through the Aries GitHub code in the Nintendo 64 section and look at the RAM code, and it's either 4 megabytes or 8 megabytes. There is no developer mode. There is no 16 megabyte RAM mode. It seems just to be adhering to the original Nintendo 64 specifications of 4 and 8 megabytes worth of RAM. And all across the board in this cutscene, you're just going to see again that the largest free and free memory allocations on Aries have more overhead. So if this is again a RAM situation and maybe it is running out of RAM, you would understand why MiSTer FPGA core would have an issue where Aries wouldn't. There is just less free available memory on the MiSTer side of things. So it's possible that when Conker, whether the retail or prototype version, is trying to read and write from specific memory addresses or general memory addresses on the core, it might be finding those areas not free. That would definitely cause a lot of problems in the game. That would explain the CPU CPU halt state because it's probably not finding the instructions it needs to go to its next step, and it could mean why we're getting that heap out of memory address error as well. But this is going to be the last crash I'm going to show you in the video. Conker tried to pick up some chocolate here, and we'll go ahead into the crash handler and you'll see why that happened. And again, all of this crash handler data is so useful. You're going to see that was another CPU interrupt lockup, and that is another interesting bit of data that we can actually use working forward to try to figure out exactly what is going on here. There's so much data in the crash handler, I won't go through all of it, but we're getting quote unquote closer to understanding what's going on here. But I'm still going to have to capture these same tests across real Nintendo 64 hardware with an EverDrive to get the last bit of data I need so I can compare all of those statistics across software emulation, across the core, and across original hardware, just to see how we're doing. And if you have any thoughts on what I should do moving forward, definitely leave them down below. But I am very interested in this. Conquering Conker is definitely something that I would love to achieve, but again, fair warning, it's as likely as I fail that I succeed. But even if I don't get 100% of the way, we're getting some really useful information which might be useful next week, next month, next year, or 5 years down the line when someone else takes a look at this. But short of that, we are done. Go play Conker, the prototype version, because it is totally playable still, and I'll see you guys next time. Bye bye.